Hi guys, welcome back to the shop. I don't know what happened, but all the channels I subscribe to, the few that I subscribe to, seems like pre-July 4th nobody did anything. They were preoccupied with something. And even post-July 4th there's still no videos being produced of the channels that I subscribe to. So I'm no better. I haven't done anything for 3 or 4 weeks now myself. So I decided to just do this video, share what I've been doing over the past 3 or 4 weeks. And one of the things is, I've been collecting parts. I'm going to seriously enlarge the 3018. So that'll be fun. And they did find a double start 500mm lead screw. So today I'm supposed to get the aluminum stuff, the frame part, 500mm. So this is going to be what? I guess Dave's shop talk. You know, if Tom can have a shop, no, Stefan does the shop talk. Okay. So I'm just showing basically what I've been doing here, a little bit of it, and actually too, you look behind me, Suncoast Precision Tools sent me this big wall poster, and I'm thinking, great, I've got no empty wall space here in the shop for it. But then I realized, perfect. Steel door, put it up with magnets, it's perfect. And in this video too, you'll see, I don't have the book here now, but I'm playing with a formula that I found in this book. And I forgot to mention, somebody on one of my videos some time ago wrote or left in the comment this formula, but they never mentioned what the variables were, what it was really about or for. So I forgot what I was going to say. Okay, so this video you'll see, and it kind of snowballed on me. I started, Suncoast Precision. You're going to see a lot of YG1 taps in here, and a bunch of them came from Suncoast Precision. So if you guys like these taps, go visit them. But this video kind of snowballed. You'll see I started playing with the formula, and next thing I know, I'm doing all kinds of weird stuff. So you got to play and learn and do whatnot. So I hope you guys enjoy the video, and I'll see you next time. Just had to record this. These are the YG1 taps that I was talking about from Amazon, and I'm using the Tap Magic 4 aluminum. But normally with a tap I have to go in, come out, go in, come out to clear the chips. These holes are a 1/2 inch deep. I'm going to go in until I just hit bottom. And there's very little force that has to be used to do this. I know my hand's going to be swinging right in front of the camera, but it just goes in and the chips just come right out. I'm not sure how deep I am yet. Lower this a little bit. It just goes in. This saves me a lot of time, I cannot tell you. There, just bottomed out. So that's a full 1/2 inch deep tap. Ow, whacked it. And they just come out in one long thread, boy. So I highly recommend these guys. I also used to have to use the taper tap first and then a bottom tap. You saw this is a bottom, and this is a real bottom tap. It is square to the very end, goes all the way down, and I can start the tap with it. First up, I'm not sure where, I can't remember how I got turned on to this book, but I remember looking at it on Amazon, and it was bloody expensive. There's the title of it. So I went on eBay and found this one, great condition, $40, free shipping. It was from some bookstore, I guess, on eBay, and 1946 published. But I'm not that terribly impressed with it. I did go through a lot of the pages and stuff, and a lot of it's more history for me, you know, how things were done back in 1946. They don't have a whole lot of I was hoping for ideas on projects and making tools and things, and it's not in there. It's more how to do things. Cutters, how you do it on a lathe operation, so on. Oh, that's the first time I saw a 5Cs in here. What else? Yeah, knurling, you know, there was a bunch of different things in here. So I have done quite a bit of reading. There was a section in here on shapers, and it had the tools and angles, and I did scan that, and I sent that to Matty's workshop in Australia, since he's got a shaper for what it's worth. Is this the shaper? No, Helix junk. So, I don't know. Nice book. I would say that other machinist book is far more information and useful that I showed in a previous video. Guys, they do have question and answer sections, so that's kind of interesting. Like, this is what a class book. Man, whoever did this, though, this is a lot of work to type all this stuff up. Chat. Different sections. Index is kind of weird on it, but so that's the first thing that I just wanted to share if anybody's interested in going after that. Next thing was I'm trying to make a holder, a mount for a camera, and you cannot, I mean, hold on the mini lathe or any which way. That's a 1/2 inch 14 thread. Could not do it. I mean, I've got giant wrenches. It's slipping in the forejaw. I tried to put it in the bench vise. No way. I couldn't even thread plastic. I mean, I had a monkey wrench on the threading die, and it just, the thing was just spinning. It's ridiculous. So it kind of goes together, but I figured I don't have any internal threading tools. So I went on eBay and I found 2 micro 100s. These, and they weren't that expensive. This is one of them, but I'm tired of also not having or having to break down a tool to put a new tool in it and redo the height, and then you have to put it back together when you're done. So I started making a batch of 3, which makes things really easy, because you have the vise stop, put it in there for like our face mill, and put the next one in, face mill, and so all of these are exactly the same and really easy. DRO set up. You just do your cut to depth, over, next one, cut to depth, over, and so on. But so the one of them I was going to dedicate to this. The other 2 were going to be something different, but I blew it in this thing because I just kept banging them out, and I put all the holes in the center, which you can't do if you're going to put a regular cutting tool in it. So I started, and then I realized, oh man, I blew it. So this one's scrap, no fun. This one's done. I need to get the right size screws to finish it off, though. So I have a good one, and this guy actually goes to the 14 threads per inch depth. So, oh, I did have an outside one, so I did go over this again with the threading tool, you know, doing the passes, and got it down to spec. Or actually, I think I took it down further so it would sort of go in there, but now I've got the tool that I can do that with. I haven't done it yet. Completely forgot I had this tool in the drawer. So I wound up making this one, since I had all the holes on center, for this guy. But the curious thing is the angle. I don't know if you guys can see it, but this is the flat, and this guy is angled that way. And I can't remember where I bought it. There's the box for it. I think it says Grizzly on it, doesn't it? Minimum, no, it doesn't. Yes, it does, right here, for Grizzly. So I must have bought this maybe off Amazon, but it's a Grizzly part. But I'm going to try to make it work. This one doesn't go all the way down to 14 threads deep, but I'll have it, you know, if I have to go deeper, because this is going to distance. So if I need to go way deep or something like that, I'll have this. Hopefully I don't have to do 14. But, and then the other one is just incredibly small. I figured, let me just get it, because that looks like fun. The minimum bore is like 100 thousandths, I think, or something it was. I couldn't salvage, I was going to salvage this for this, but I didn't drill and tap the holes deep enough. Just deep enough for this guy. And same way for this one. Well, actually, I did drill it for this one, and that's why it worked on that one. But so I have this guy for whatever reason. I think it was like $10, $15. I'm like, okay, I'll take that. Micro 100, sure. Curious thing, though, in doing the face mill, it was going fine, and then all of a sudden, in one direction, it was just shredding the surface. The other direction, beautiful. So I had to replace them. I had other ones. But I'm looking at this underneath the stereoscope. These came from Banggood. They're carbide. How do you chip carbide on aluminum? That was really curious. It's flat out chips. There's missing chunk on the outside face when I was going that way. You can feel it with your fingernail. So I'm really curious, and there's nothing I can do, I don't think, to save these guys or put them on a, D-bit grinder. So I had ordered another pack of 10. It was like $20, and they came real quick. They came from the U.S. warehouse, I guess. So, one other last curious thing, $2, eBay. It was listed as a deburring stone. And for a couple of bucks with free shipping. It's meant for skis. I'm guessing snow skis. So I picked it up and I played with it on a few things, and I don't know how you're gonna deburr a big snow ski with this thing, but I don't know. I thought I tried it on something, but I can't remember. So that was just one other thing. If anybody wants to mess around with a teeny little deburr thing, next time I do steel or something, I'll probably try it. But I always use just a regular stone, sharpening stone. So I think that's it. All I've been doing here since I did the last video weeks and weeks and weeks ago. I am finding some stuff in this book interesting. Just thumbing through it, I don't know what page it was on now, but it started making me go back to the beginning and actually start reading it from cover to cover. Someplace back in here, they showed a precision square for a granite surface plate. It was shaped like that. It had indents in it for the fingers, so you didn't touch the edges because they were precision. I think it was at Brown and Sharp 559 or something like that. I went on eBay just for grins and giggles, and yeah, $300, $400 for them. Old, used, pre-owned, and the edges do not look too good to me when you hover over and zoom in. For those of you who watched a previous video where I was checking all of the other squares from my square set, they're perfection. That is a perfect surface plate, square, whatever thing. They sell these on Amazon. You can get a 3-inch, 4-inch, $10, $20. So that's just, I realized that, I've got a whole set of precision absolute square stuff. The other thing was back in here. Yeah, they do call it a micrometer caliper, technically. So everybody's shortened it and they call it a micrometer or a mic. But the other machining fundamentals book also I learned, it's called a micrometer caliper. But they talk about the hole, and I was always thinking, the little calibration hole here, that yeah, you spin it on a friction fit for the first time to calibrate it. They're saying no, it's to compensate for wear in the nut in the lead screw. So if you have a very old mic, you may want to double check its calibration. Mine, yeah, when you buy something this expensive and it's supposed to measure tenths, mine, yeah, is zero, lands right on the money. So I thought that was interesting to learn, you know, that these things wear out. I mean, really? The other interesting thing that I just decided to record, I bought this off of Amazon just for fun or whatever. No, I actually bought it because I wanted to make threading tools, you know, 60 degrees for threading on the lathe. And I know it was pretty cheap, even being a mid-tutorial. But these guys, I don't know why they picked the numbers. There's 32, oh, I can't even read it, huh? 32, yeah, 32, 24, 14, and 20 threads per inch. So you can actually hold this, you know, this is a 12, and I held it up, and yeah, it lines right up. So it's not only for making your tools, you can kind of use this as a cheap thread gauge, a quick one, rather than buying the thread gauge set. But the thread gauge set gives you every one that there is. But the real interesting thing is the table on this. They don't go very far. I think it was like 28 threads per inch is the highest they go. I need to find a table that goes all the way up. But these numbers are, for instance, if you wanted to do 12 threads per inch, then there's a double depth number here. And what that means, double depth, is it's, I don't think point with but this, the depth of this side plus the depth of this side, double depth. So if you want a perfect V, what do you call it, V thread, you take the diameter, like if we're going to do a 3/8, you take 3/8 minus the double depth. That's the drill bit you use to get a perfect V. And I did check it on a 3/8 24, and sure enough, what they recommend is oversized by quite a few thousandths. So that's where these numbers are, double depth. And like I said, I want to find a table that goes up to like 32, right? Yeah, 32 threads per inch, because I got, you know, 632, 832, 1032s, and I'm doing that a lot. And yeah, when you put the screw in there, it's kind of sloppy and rocks. So it'd be fun to actually drill a hole and tap it where I'm going to get a full thread and see what it's like. Because with it oversized, you're missing the peak of the V. You're drilling the hole bigger. So you're getting the depth, but you're missing the point on it. I should look at some thread. And all the threads I remember looking at seem like they always have a point to them. So I don't know. I'm going to just keep going through this book because this is interesting to pick up some of this stuff. Cut a little too soon. I'm saying, you know, I got to find the chart for all of these. You turn the page. Oh, come on. All right, there we go. Jeez, I'm thin pages. Really? There, finally. There's the formula. I guess I'll turn it over so you guys can see it. And they say the diameter of the tap here for D. So luckily with the YG1s, I can measure the outside diameter of the tap. 3 points, you're not going to get there. So I did put the caliper on it, and I'm getting anything from 190 thou to 193 for a 1032 tap. So I've done some math here already. Boom. I can get it over there in the camera view. I think, yeah, that's in the camera view. I don't know if you guys can read it, but there's their formula. And I punched in 0.190, the minimum that I was getting. And it says it should be a 149 thousandths drill bit to get a perfect V cut. Now, the chart for all these, for a 1032 says you use a number 21 bit, which is 159, 10 thousandths bigger. 22 is 157, and so on down. The drill bits are actually undersized, so that's what all these numbers are. A 159 bit actually measures 157. So I'm thinking, let's do some drilling here and tapping and do some experiments and see how it comes out. Alright, I'm going to use the Drill Hog Mollies because they're split point, and I think that'll give me a better hole, a more accurate hole. Alright, so I've got it marked out just to make sure I can make it on this junk piece of aluminum. Every ½ inch a hole. DRO is up and running. Zero it out. Alright, so the first drill bit I need out of this set. I guess I'm going to do the largest hole first. So that's a 21 bit, right? Yeah. There's the 21. Right, 21 bit. Alright, get him in there. And chuck key. So I need to line it up. Oh, everything's locked. Line it up on the first one to drill, right? Actually, let me drill it further away so I can mark what this is. Marker. Okay, so this is the 21. Boy, that's hard to write. 210 at the DRO, so I know where I'm going. Alright, ready to go. Let's drill. I'm not sure how far down. I gotta re-zero it again. I'll go down a ½ inch. Alright. I'm Chip City, huh? Yeah, hold my hand here. Sorry about that, folks. Alright, 100. 200. No, almost 200, now 200. And 300. I'm just probably going to just do the rest of this off camera. That's 400,000 right there. 450. Yeah, ½ inch. Alright, I'm going to do the rest of these holes off camera. Alright, set for tapping. All the holes are deburred or drilled, and I was just deburring the last hole just for fun to see what happens. So 24 should be the smallest hole, 21 the biggest hole. So I got my tap here, and I know my hand's going to be in the way again. But we're going to do all of, oh, I'm on the last hole. So this is the smallest hole, right? Yeah, I get it, yeah. So how's it going to work? It feels fine. Yeah, it's not too bad. It's about as, maybe just a tad stiffer or harder than normal. And then we'll try the, I think that's the bottom. I'm not sure. I don't want to break this tap off in there. I don't know what to say. Then we'll just try a screw in there and see what it's like. But that's significantly smaller than they require. Undo that. I got to move to 1 inch mark. 200, 100. Looking at the touch of DRO here. 4,210. Alright, I'm on it. Put more magic juice on there. And we'll take this one in. So, I guess I'll do the rest off camera. And bring you back when they're done. Blown out. Oh, this is stiff. Oh, that's pretty tight. For some reason. Yeah, that is pretty tight. Maybe I didn't put enough of stuff on it. Boy, that's real tight. I don't like that. Next time I'll make sure I blow this thing off and then... Wow. Blow it off, make sure I put a bunch of juice on it. There, it's cleaned up. I guess move this over for the next hole. ½ inch. 7, 6, 5, 18, 9, 0. Okay, drown the thing, huh? Yeah, make sure I got a lot on it. I wonder why that one was so tight. This should be pretty easy here. Yeah, it's pretty easy. Yeah, this is about as much force as the first hole. This is quite a bit of force I'm getting here, though. It's a little bit on the scary side. Yeesh. Not sure when I'm hitting bottom. I'm gonna quit there. Might as well do the last one on camera then. What the heck, you know? See what that force takes. Very interesting. Alright, move over to 0, 100, 7, 4, 3, 2, 1, 0. 1,000 too far. Blow it off again. Now this is the hole with the recommended drill bits. Oh, this should be really easy, huh? You think? I'll just have to get a 1032 oh yeah, blow it off, get a 1032 screw. Yeah, there's force, but yeah, it's easier. Yeah, it's definitely easier. Okay. I'm sure that's down a lot, so. Alright. I just need to get a 1032. I'll use a stainless screw. There it is. Put that off. Blow junk all over the place here. Yeah, holes are clean. Imperial stainless. Where are you? Alright, this is it. 1032. Let's try it in this hole. Goes in pretty tight. And yeah, there's some wiggle to it. This one. Feels real easy going in. And there's the same amount of wiggle to it, huh? This one. Easy going in. And the same amount of wiggle. So this would be for full depth right here. Yeah, of course the phone would ring, telemarketer. Come on, get in there. Easy going in. And wiggle. So I don't think it matters, huh? When you get further down, oh, I bottomed out. Very little wiggle. Let me go back to the original size here. The recommended drill bit and go down pretty far. And go down to the bottom and then back up a little bit. That's close. Yeah, there definitely is more wiggle here than that hole. So, conclusion, I don't know. I'll probably just keep using the recommended, or maybe sometimes come down a little bit.